In this example, we want to evaluate a couple of limits involving absolute value. So let's start with A. We have the limit as w goes to 3 from the left of the absolute value of w minus 3 divided by the quantity w squared minus 7w plus 12. So when we're working with absolute value in calculus, we really need to slow down and give it some extra thought. Here's the basic consideration. So let's just consider the absolute value of x here. And this fact is that the absolute value of x is equal to x. It's just itself anytime x is greater than or equal to 0. But then we replace x with negative x anytime x is less than 0. So that might be a different way of looking at absolute value than we're used to, but take a minute to justify to yourself that it works, right? Say we had something like absolute value of negative 5. Okay, well, this tells us that if x is less than 0, which is the case, we replace x with negative x. So this is telling us that we replace this with negative that, so negative 5, which is 5. Well, indeed, the absolute value of negative 5 is 5, so it checks out. Right, this is a very simple case, but we use it to evaluate these more complicated absolute values. Okay, back to our example. W is approaching 3 from the left. That's what this negative up here means, of course. If W is approaching 3 from the left, then it's always going to be less than 3, which means that when we take W minus 3, that's going to make this whole thing, W minus 3, less than 0. That's without the absolute values. All right, so at any point, if you need to pause and think about that and make sure you're on board, feel free to pause and just make sure that all checks out, that W minus 3 will be less than 0 anytime we're approaching 3 from the left. It might help to just think of W as, I don't know, let's say 2.9, right? That's approaching 3 from the left. 2.9 minus 3 would be slightly negative. So sometimes it just helps to just pick a value close to 3, but to the left of 3 on the number line. It helps one wrap one's head around this. Okay, so W minus 3 is less than 0. Well, then our fact over here tells us that since we're taking the absolute value of it, and it's less than 0, we need to replace W minus 3 with negative W minus 3. Negative quantity W minus 3. So let's clean this up a little bit here. This limit becomes the limit, okay, as W still goes to 3 from the left. And now instead of absolute value of W minus 3, we have negative quantity W minus 3 all over this denominator. Well, I'm going to factor this denominator because I'm hoping some cancellation happens here. We have W and W. How about minus 3, minus 4? And look at that, ripe for cancellation. There we go. So that brings us to the limit as W goes to 3 from the left, which now it doesn't really matter which direction it's approaching it from, negative 1 over W minus 4. And at this point, it's just a rational function, so we can simply plug in for W. So this is negative 1 over 3 minus 4, which comes to negative 1 over negative 1 equals 1. We have to admit that it's tempting to just drop the absolute value, and unfortunately that's what a lot of students do here. But now we know that anytime you see an absolute value with a limit, it means you need to slow down and really consider this fact here about absolute value of x. Okay, I think we have the hang of this now. Why don't you try B on your own, and then we'll compare notes. So for B, we have the limit as x goes to 5 of the absolute value of x minus 5 all over the quantity x squared minus 25. Pause the video, try that one on your own, use this fact about absolute value, and see if you can get that to come out. I'll give you a hint. Examine the limit as x goes to 5 from the left and the limit as x goes to 5 from the right. Okay, let's take a look at this one together. Let's begin by taking a look at the limit as x goes to 5 from the right of absolute value of x minus 5. Okay, all over x squared minus 25. And we'll also do the limit as x goes to 5 from the left of the same thing. Absolute value of x minus 5 over x squared minus 25. Okay, well, as we go from the right, we're coming in from the positive direction. So you can imagine something like 5.1 for 5, just to get an idea of what happens inside here. If we put in 5.1 for 5 and subtract 5, this whole thing inside the absolute value will be greater than 0. And that'll happen for any value just to the right of 5, or really anywhere to the right of 5 on the number line here. So as we're coming in from the right, we are greater than or equal to 0, so we replace the absolute value of x simply with x. Absolute value of x becomes x. So here we go. This becomes the limit as x goes to 5 from the right of simply x minus 5 on the top over. Now I'm going to factor that denominator there. X plus 5, x minus 5, x minus 5. Okay, look, we get some nice cancellation. So we now have the limit as x goes to 5 from the right. At this point, the approaching from the right doesn't really matter. It doesn't change anything, of 1 over x plus 5, which is 1/10. Okay, moving on to approach 5 from the left. Now imagine something slightly to the left of 5 on the number line. So I'm thinking 4.9. Okay, so if I put in 4.9 here for x, 4.9 minus 5, that's going to make this whole thing slightly negative, less than 0. And in fact, that'll happen for any value of x that's less than 5. So anytime we're approaching 5 from the left, our absolute value, the quantity inside the absolute value will be less than 0. Well, if the quantity inside the absolute value is less than 0, then to evaluate the absolute value, we replace that quantity with the negative version of that quantity. So we then have here the limit as x goes to 5 from the left. We replace the absolute value with negative of that quantity, so negative quantity x minus 5. Make sure you put parentheses around that. All over, okay, x plus 5, x minus 5. Same cancellation. So we have now, we can evaluate this limit. It becomes negative because we have this negative out front, and then we have 1/10 just as before. Okay, well at this point we need to remember this fact about limits, which is that a limit exists if and only if both the one-sided limits equal the same thing. Well, in our case, they don't equal each other. Negative 1/10 does not equal 1/10. There's only one thing to conclude, that this limit does not exist. And that's our answer, which we often abbreviate as D and E. So imagine what a tragedy it would have been to have just dropped the absolute value, like it's so tempting to do, and then evaluate the limit. We would have gotten a completely wrong answer. So I implore you to please use this fact anytime you see an absolute value. It really makes a difference.